Hello friends, today we are going to solve a few more numericals based on Kirchhoff's laws, and this is a board question. Let us solve this board question. First, take a look at the circuit A, B, C, D, and there are some components, some batteries, some resistors given in the diagram. And what you are supposed to find? You are supposed to find the current in each branch. You are supposed to find the potential difference between terminals B and D, and you also have to find the potential difference across the 3-volt cell. This is the 3-volt cell. You have to find the potential difference across this cell. Now these resistance 1 ohm, 2 ohm, this 1 ohm and this 3 ohm, they are the internal resistance of these cells. Internal resistance means they are not connected from outside. The cells themselves have got these resistance. That means actually this 3 ohm resistance is located inside the cell. So whatever calculations you have to do for the cell, we will have to include this 3 ohm resistance. So what is the first step we are going to take? The first step will be to distribute the current. Okay, this we will do with the help of Kirchhoff's first law. This is how the currents are distributed. This is my method of distribution. You can have your own method of distribution. Say suppose I have started from this point, current I is coming from this battery, and at this junction the current gets divided into two parts. I1 flows this way, I2 flows this way. Okay, I1 continues up to B, I2 also continues, it passes through C, then it again reaches B. At terminal B, I1 and I2 both currents will combine, and because I was distributed as I1 and I2, so when you add up I1 and I2, what you get is current I. So this is the first equation I will write, that I is equals to I1 plus I2. This is the first equation, and now applying Kirchhoff's second law, and before I apply Kirchhoff's second law, I have to select a loop. Now what loop I have selected is loop ADBA. Can you see that loop? A, D, B and back to A. So I have to add or I have to subtract the potential differences. You know when to put the plus sign, when to put the negative sign, when you are going along the current or when you are moving opposite to current. And when I go through this loop, this is the equation that I get. 1I1 plus, see from here, it is 1 into, I. Then because I am touching the positive terminal of this cell, I have to write it as plus 1. Then I have to go through this 2 ohm resistance, which is again I am doing along the direction of current. So this will be plus, resistance is 2 and the current is I1. So plus 2I1, then going to B, and then from B touching the negative terminal of 2 volt. Because I am touching the negative terminal, it will be minus 2. Again, because I am going along the direction of current, it will be taken as plus. So plus, resistance is 2 and the current flowing is I. Okay, now solving this equation, 1I plus 2I becomes 3I plus 2I1, and this is the final equation. 3I plus 2I1 equals to 1. Similarly, going through another loop, that is loop DCBD. Can you see the loop? DCBD. Now again applying the same thing, taking plus and minuses, and this is the equation that I get. This is the equation that I'm getting, and now from this, solving this equation, simplifying this, will give you equation number 2. I1 minus 2I2 is equals to 1. Now after you have done this, you have to first check that none of the equipments should be left out. No resistance, no battery should be left out. Either it should be in equation 1, either it should be included in the first loop, or it should be included in the second loop. Clear? Now these equations, I have got equation 1 and equation 2, and now there is a need to solve these equations to find the values of I1, I2 and I. You can solve these equations by elimination method, substitution method, determinant method as discussed earlier. You can have your own choice to solve these equations, but you should get the values of the three currents. This is what I get. I1 equals to 1 by 13, I2 equals to 6 by 13, I3 equals to 5 by 13. So this is the answer of the first question, that I have determined all the currents in each branch. Now let us go back to the question. The question is also asking to find the potential difference between B and D. Can you see the terminals B and D? What is the potential difference between them? Now how do we calculate potential difference? This is by V equals to I into R. Okay, current into resistance. So what is the current flowing through between B and D? It is I1. What is the resistance? 2. Do I know the value of I1? Yes, I do know the value of I1. So I simply multiply this current with the resistance, and this is what I get. Very simple. What is the resistance? 2. What is current I1? It's 2 by 13. 1 by 13 into 2, it becomes 2 by 13. So what is the voltage between, or the potential drop, or the potential difference between B and D? It is 2 by 13 volt. That's it. Now again going back to the question, the potential difference, what do you have to find? The potential difference across the 3 volt cell. Here you see the 3 volt cell and the potential difference across the cell. See, the cell is of 3 volt, but the 3 volt is EMF of the cell. It is not the potential difference. How to find the potential difference? Use the cell equation for that. Okay. Now what is the cell equation? Cell equation says that E equals to V plus IR. What is E? It is the total EMF of the cell. What is V? V is the potential difference across the cell. What is I? I is the current passing through the cell, and small r is the internal resistance of the cell. This is a method to find the potential difference across the 3 volt cell. Now, just rewrite the equation in terms of V, because you are asked to find the value of V. So V is equals to epsilon minus IR. Now very simple, just put the values of epsilon, EMF of the cell, how much it is? It is 3 volt. What is current? Current is I2. Do I know the value of I2? Yes, it is 6 by 13. And small r, what is small r? Small r is the internal resistance of the cell, which is 3 ohm. Just put those values. This is what you get at the end. It is 1.6 volt. So you can now see that EMF of the cell is 3 volt, but the potential difference across the cell is not 3 volt, it is 1.6 volt. Okay, this is how we solve this question. All the 3 parts: finding the currents, the potential differences. And now, based on the same concept, I have one more question. This is the question for you to solve. See what you have to find. You have to find the potential difference between terminals A and D And also take care, one thing is mentioned in the question, that no current flows through BE. Okay, please note down this question, and then we will do something very strange. There is no current between the terminals B and E. So when you start solving this question, because no current flows through this branch, just eliminate this branch. Just eliminate this branch. Okay, because there is no current flowing through it, we are not concerned with that branch. Now you can take a simple loop from this. This is also a CBSE board question. Clear? It's very easy now to solve this question.